Hello my friends, welcome again to my video channel. Today we'll start a new project. Simpson analog multimeter type 260 series 7M. I already have one of these multimeters and I've repaired it. The link is in the description below the video. You will find it. It was on the internet offered for some euros, extremely cheap, in bad shape optically, and the owner said it is not okay, doesn't work as it should. So I got it very cheap. The price for the postage was higher than the price for the multimeter, as I remember. So I couldn't resist, and in case if I would fail, okay, I have a new case. My other multimeter has a damaged case. I could use it for parts, but I hope it is not so bad and we can repair it. So let's start. This series has, as all Simpson multimeters from this series, the reverse banana plugs. Normally we have a pin which goes in, the connector is there, but there's a different, the pin is inside. And this is a connector which comes from outside. It's a reverse. The cable was part of the supply. Now we will check it, the accuracy, and compare it with a digital multimeter. First test in the DC range, 10 volt DC from my power supply. Here we measure in the 10 volt range, we measure only 8 volt. When I go to 50 volt, we measure much less than 10 volt. We only have 5 or 6 volt. When I go up to 30 volt, that's the maximum I can achieve with this meter and power supply. 30 volt is here. We are measuring 22 volt. So the DC ranges we have much to less indication. When I go down to 2 volt, .5 should be full scale. We measure 2 volt. There's a constant error which indicates that there is something wrong with the calibration or with a divider. Let's go to AC measurement. In the AC range we have a complete different behavior. With 183 volt AC from my variac, and this is true. I'm measuring also on my variac on the meter 190, a little bit less than 190 volt, 180 volt. We are measuring 250 volt in the range, and I'm on the right. Yes, it's right input. AC here, plus minus, that's correct. So it's indicating too much on AC. Interesting. Let's check the current. The milliamp range is dead. I cannot have any indications. A very low indication, but should be approximately 100 milliamps. The current is set to 100 milliamps. I checked it with the digital meter, it's okay. There are other inputs. 10 amp range. I could check the 10 amp range. One moment. Milliamp and 10 amps. There's current flowing, but no indication. 2 amps, 3 amps, nothing happens, but we have a short, of course, from here to here, as it should. There's a shunt inside. This also is working, but no indication at the current ranges. Okay, I don't check the other ranges, the AC and the ohms. There's a lot to do. Let's have a look in it. First we open the battery holder. Okay, we see some corrosion. Here's a corrosion. Oh, this contact is corroded, heavily corroded. It's corroded away. The 9 volt is also. Aha. Well, the battery holders have to be replaced, but that's not a problem in the moment. We will now remove the cover. Well, it looks not so bad as expected. The switches are clean. Obviously no contact problems. This one is a little bit too green, I think, or is it the color? We will see later. These are the pots for the alignment. What is this? Someone has unsoldered this resistor on one side. Nice, nice. What is this? Someone made a bridge. These are the diodes for the rectifier of the AC measurement ranges. But someone made a bridge from here to here with a wire, but it is not soldered, it's just wrapped around. That's it. Interesting. Bad contact. But when we look into the board from the other side, I do not see any signs of overload, of burnt traces or so. Only the modification with the resistor here is a little bit strange. Why did someone take away this resistor? Soldered it out. Is this the reason why the current measurement range is not working? And what is this bridge here good for? Let's have a look into the schematic. First, let's check this resistor. When I go to the layout, it is R14. This is R14. You can compare it. Second from the left, the small one is R15, it's R14. And R14 in the schematic of this one. It is in the milliamp range, 500, 100 milliamp, where we had no indication. Remember, and of course, when we have here an interruption, when this resistor is unsoldered, then the signal is not connected via this contact, which is set here to the plus pole. The common positive input is here in range DC. It goes there, it goes there, it goes, this contact is here, goes there, and then it should go via this resistor to this contact, so that this contact feeds it here. But when this is interrupted, we cannot measure. In the 10 milliamp range we should have, or in the 1 milliamp range we should have an indication. I didn't check it. But in 100 and 500 milliamps there's nothing. This resistor is missing. And the other thing what I have seen, the original resistor is 22.5 ohms. Unless otherwise specified, resistors are in ohms. That's what I know. Ohms. 22.5 ohms. And this resistor has 22 kilo ohms. And it was soldered in by someone, because we can see here this solder connection is not original, and this also not. And here we have a wire, and it looks like it was pinched off, and then a resistor was soldered in. But this hero took 22 kilo ohms instead of 22 ohms. Oh my god, oh my god. There is a bunch of idiots outside. Sorry, it was necessary to say it. And here, this connection is the resistor R2A to anode of D2. R2A to the anode of D2. And in the schematic, it is this resistor R2A. We have here one pin, and anode of D2 is here. But this wire is the same as this. So effectively, this bridge, what we have here, is shorting out this resistor R2A, the 2.2 kilo ohm. So the meter is more sensitive because we have only R2 in series and not more. That's what we have seen, that in the volt ranges, in the AC volt ranges, we have more deflection, but in the volt ranges we do not have. Why don't we have no more? Because in 10 volt we have this row and it goes there. Maybe someone has tampered with the setting here also. Okay, first step is to check this one, replace it by a new one, and to unsolder, or unsolder, not to unwire it. It's only a wire which is made wrapped around to remove it. I do not have 22.5 ohms and it's difficult to purchase them. So I will use 3 resistors, 68 ohms in parallel. Theoretically it should have 22.666, and when I add another approximately 10k in parallel, I have to check where I am when I add these 3 resistors in parallel with 10k or similar in parallel. I should reach 22.5 ohms. So first I look for 3 resistors, 68 ohms. I use metal film resistors, of course. And then we see where the resistance is. I took out this resistor. Now I have to remove the old solder. I use some solder braid to remove the old solder. I think it's the best way in this case. No, there is still solder. Maybe there is some solder in which is not. I have to hold it through. And this hole is also through, yes. Both holes are correct, right? And then I will clean it. By the way, I soldered 3 resistors, each 68 ohms in parallel, and added, as I have calculated, 10 kilo ohms in parallel. So I have 22.5. I measured it with my ohm meter, with my digital ohm meter. That's accurate enough because it's not a precise instrument. I only want to have the same value as in the manual is stated. Now I remove the old solder and the flux. I use some cleaning gasoline. You could also use isopropyl alcohol or similar. The replacement resistor or resistor combination is in place. You may ask if it's not a little bit too weak. I'm sure not, because when I have a look at the board layout, this R15 is smaller than the R14, which we have replaced, is double the size, but R13, the big one, is much bigger. And I'm sure that this is adequate. And on the other hand, we are in the range of milliamps measurement, so I cannot imagine that a 22.5 ohm resistor is overloaded in the range of milliamps. So I think it's okay. And the unfortunately the schematic does not state the power rating, but I think it's not a critical term. Well, next topic. Stop. Yes, it's also stop. Is this wire. We will remove it. The resistor and the diode looks a little bit damaged. I hope it's not broken inside. And now I will do a first electrical check whether we are in the range what we expect. And now, big disappointment. Nothing works. 10 volt range not. I have 10 volt input. 20 volt, nothing happens. 2.5 volt, nothing. When I go to the current, I measure the short circuit of the power supply. It is limited. Also nothing. Worse than before. What happened? What did I do? Okay, I added the resistor, but I removed the short. Is the short, or was the short a repair? Or what was it? Looks like someone has soldered also here with these diodes, with this resistor. I will try something. I will add this short again, what we have removed on the rear side. Now I'm in the milliamp range, 500 milliamps. Now I have a current. Okay. I'm going to go to 10 volt. I measure the output voltage. Again, it is 10 volt. Okay, it's 8 volt. I'm sure I can adjust it with one of these pots. This one? No, this one. I have to look for it. But oops, nice. 0 ohms. But now we have deflection. This means that the short was a repair. But repair for what? It's getting worse and worse. The bridge what I made with the croco clip was a replacement for a missing connection. The minus pole here of the minus 10 amp measurement range is not connected. It's connected to the connector here, but not internally. There should be a wire. It is unsoldered or it is broken. Don't know what happened. It should go to there anywhere. This connection here looks like someone tried to solder or resolder it or unsolder. Here we have some bad solder connections. What is this here? This is also someone used solder without flux. Ugly. Why did someone here also? Here. What is this? This happened to me when I took out here the connection. It has to be connected here. That's the plus pole of the 10 amp resistor, but this minus pole has to be connected to the ground, to the reference, as we can see here, and to here, the minus of the battery, and here. And this is not connected. We only have a connection from here to here, but this is not wired. And I feel there are some other problems also in. Luckily, I have a second one of these multimeters, and I will check it and compare it to see where bridges are missing or where solder connections are bad. It's the easiest way for me. Now I've seen another problem. One of these diodes is in the wrong orientation. The schematic says that cathode is connected to the anode of the other diode, and D2, the cathode of D2 should be connected to the R25. R25 is this one. Yes. D2 is this diode. This is D1. Yes, it's D1, this is D2. And this pin here is connected to this resistor. We can follow it. This pin, and here we have a trace up to this resistor, and here are the both diodes connected together, and we see someone has soldered here, and this diode is in the wrong orientation. It should be flipped around. No. What the heck did this guy? I've opened my working multimeter, Simpson260, to compare it. Here we have the original resistor we replaced, 22.5 ohms. That's okay. Next is the orientation of the diodes. As assumed, this diode is wrong. It should be this way. The other one is this way, should be this way. Here they are connected in parallel. Cathode of one is connected to the anode of the other. That's rectifier for the AC measurement. Here we have both anodes connected together. Not correct. Why this happened, I don't know. Next topic. This resistor here is 2, 7 and gold. That means 2.7 ohms. The right one has red. That is 2.2 kilo ohms. 2200 ohms, not 2.7 ohms. Someone swapped this resistor and replaced it by this one. It is a serial resistor. This one, which is in series to the meter. Here we have a variable pot with 3 kilo ohm and 2.2 kilo ohm in series to shift the setting range up to 5 kilo ohm. This is replaced by 2.2 ohms. I really don't know why someone did this, maybe to increase the sensitivity. And the diodes were wrong, so this common point where I first assumed it is here. It is here because the anode of D2, where it is connected, where it was connected here, this anode is the anode also of D1. That is this point. So this point is wired to this point. So the 2.2 K, or in this case 2.7 ohms, are bridged. And I really don't understand how the AC measurement works now. It's a little bit difficult. Here we have no connection to the ground line. As we have seen, there's an interruption. And this is a third problem. We see here that this resistor, the end of the shunt resistor for the 10 amp measurement, which is the ground, is not connected. When we have a look at the right one, we see there is a wire connected. And the wire which is connected here correctly to this side is connected here to the other pin. It is existing, but it's connected. This purple wire is not connected to this one, where it is connected here. Soldered, tack soldered rather badly. I don't know what happened. Someone took it out, I assume, and wired it to the wrong side. There are signs of soldering. What to do now? First, swap and check the diodes, replace this resistor, and rewire this connection. 3 topics. I took out both diodes. I want to check them using some soldering braid. It's the best way to get it out and to clean the contacts. The resistor is also out. And now I will connect these 2 diodes to my component tester and see what it says. Both diodes check good, as we can see. This is one, the other one is also good. Luckily we don't need new diodes. Would be difficult to get adequate diodes with the right characteristic, but it's not necessary. They are good and I will solder them in again. The 2 diodes are in, now in the correct orientation. The resistor 2.2 kilo ohm is in. This connection, the purple wire, is now connected to the right side. It looks a little bit ugly. I will replace it by a new one. I will swap all the connectors from these inverse banana connectors to real banana connectors, as I did with my other Simpson. And here I resoldered this broken wire. Maybe I have broken it when I opened the case. I'm not sure. It's a tap of the 10 amp measuring range. Well, now it should work. Let's check it. And we see nothing. In all voltage and current ranges, in DC measurement, no reaction. I have to check the meter itself, but on the other hand it worked, as I remember. We have seen that we only have an error, but in the moment we have no deflection, nothing, not in the current or not in the voltage ranges. I didn't check the ohms, but it's not important to check ohms as long as voltage and current does not work. I will check the meter itself and come back. I have here a voltage of approximately 1 volt or less, limited with milliamps, and I will go to this measurement point here and here, plus pole, and I use these 2 resistors in series, this trimmer and the fixed resistor we added, and see whether we can get a deflection. Here we have the plus pole. I go to the resistor without trimmer. Okay, we see there is life. I go to the trimmer. When I go to the other side of the trimmer, no reaction. And the 3rd pin, also no reaction. It looks like this trimmer has a problem. It has no continuity. There should be a reaction. Not very big, but at least some reaction. Do we have a short here? No. We'll make a short. Okay, current limitation is shown in the power supply. Here we have reaction and here no. So I will take out this pot and see what's going on in this pot. I've forgotten to mention that the R2 and R2A are wired in this way, a different way. R2A is connected directly to the meter, and the trim pot R2 is connected here to this switch. So the contact we had where the bridge was bridged out R2, the bad trim pot. The trim pot was shorted out and not R2A. And this was the reason why the instrument worked with this bridge, and it didn't work when I removed the bridge, because then we had to rely on this R2, and R2 is bad. So that was the reason why I could get an indication on the meter when I connected the power, the volt to here and also to our 2 pot on one side, and the other side of the pot had no contact, no continuity. So we got a signal indication here, but not here, because of the inverted sequence in the wiring. Maybe it was an error, or it was modified later and the schematic was not actual or so. That is the reason for the behavior, which is a little bit strange for those who look very carefully to the schematic. I've taken out this pot and now we'll check it, measure it with my second Simpson. I keep stylish, so I use this one. Don't know which setting it is. Measurement range is R times 100. So if this is 10K, 1K, 2K, 3K and so on. It is set to 0, yes, 0 is okay. Now I'm measuring from here to here. I measure nothing. Only at the end there's something, 500, 600, and suddenly you see, I can show it with a small screwdriver. Only very close to the end. We have a 500 ohms and then suddenly infinite. Well, this pot is not okay. I will replace it by a new one. The new pot is in. I couldn't find another pot. It's difficult because the third pin here is not used. It's only for mechanical stabilization, but from here to here we have the variable resistor and the third pin is not used. It's only provisional. To see whether it works now, I will look for a better solution. Now it works. 10 volt DC, indication is a little bit more. I tried to set the trimmer. We have installed and to adjust it. Can't see it when I sit down. Okay. But there's a parallel resistor also. Maybe it's necessary to realign this parallel. It's R1. Okay, it's on the other side with this one. It has to be done very careful to check the current and the voltage settings, because the parallel, the shunt resistor, which we have here, is for the current. When the current flows in, part of the current goes with this meter, the part of the current is shunted. But when used as a voltmeter, the series trimmer here is active. But this does not affect the current, because current flowing through it is constant, irrespective of this setting here. So current has to be aligned with this one and voltage with this one. Well, but in general we see it is okay. When I go to 50 volt, okay, we have a 10 volt. It's obviously right. Go down to 2.5 volt. .49. Yes, 2.5, not full deflection. This is an error caused by the not perfect alignment in the moment for current and voltage. So we have here an error, but in general it is okay now. Now I'm measuring AC voltage, 250 input. We are measuring a little bit less. There are also two trimmers. One is for the higher setting and one for the lower voltage setting. I don't know which is for what. I have to look into the alignment instructions. R22, R25. 22 and 25. But why does R25 not react? Maybe it's for the lower voltage ranges. But okay, in general, AC range can also be set and aligned. Not the topic in the moment. I can continue with my work. Now we are at the end of part 1. We see, for example, current measurement, nearly 100 milliamps. Full scale is 100 milliamps. DC it is not perfect. So I will do or try first a complete alignment before I continue the work with modifying the connectors to see whether all components are okay and whether an alignment is possible, complete alignment is possible and accurate as it should, or whether we have other problems, maybe some resistors drifted away or contacts are burned or so. Anyhow, stay healthy, stay tuned, see you on this channel.